Okay, here we go. I don't know why I keep repeating things. I just repeat everything all the time. We are 7.7. This video can be found at nkinfinity.com, or you can just search for it on YouTube. My name is Mr. Krause. You can call me Mr. Key. Yay. All right, let's get going. Characteristics of the sine curve. Ooh. Sounds so boring. I'm just kidding. Let's get through this stuff. This stuff's kind of cool. All right, it's not that cool, but you still got to learn it, and you'll have fun doing it. All right, let's see if we can figure out what's going on. So here is, we're going to try to figure out A. Now remember, A stands for amplitude. Amplitude. It's how high the peak goes and how low the valley goes. So this one has a amplitude of 1. Notice it goes up to 1 and down 1. This one has an amplitude of 2. Notice it goes up to 2 and down to 2. And finally, the one that's got 3 has got the highest amplitude, highest level of highest dilation. So amplitude A is really defined, if you don't have these equations and you can't just readily see it, and the graph's off in no man's land, amplitude can be found by doing max minus min over 2. That's amplitude. The magnitude or the difference between, I'm just trying to see if I'm going to get this all, the extreme values. This is why I should type everything, or the heights. It's also, in layman's terms, it's the height from the midline to the max value. And we'll keep talking about that. You'll understand that. What does changing B do? Okay, so remember, this says we're going to have one full curve in 2 pi. So that's the red one. That's red. The black one says the black one is the one that's got 2 full curves. Notice one full curve ends there, so this would be the black one. And the blue one says we're only going to have a half of a curve. So period, let me define period first for you. All right, let me define frequency. It's the number of complete cycles, or full cycles, over the interval 0 to 2 pi. So how many full sine curves do you see from 0 to 2 pi? Normally we just see one. Normally we just see this red one here. We just see one full curve. As this increases or decreases, as it increases we see more cycles. As it decreases we see less cycles, which is why the blue one only has half, or the top part of it. The period is the length of one cycle. The length of one full cycle. So the period is equal to 2 pi, which is the length normally of one full cycle, divided by b. So that's why if the red one is the sine, notice what b is. It's b's 1. So 2 pi over 1 would just be 2 pi. So the normal time it takes the normal period without any transformations, is 2 pi. Now, why do I need x scale? X scale sometimes helps us out determining what scale we're going to put on the graph. And the easiest way to do that, because really what I want are, I always want to start at 0, and then I need 1, 2, 3, 4 other points after that. So what I do is I'll take my period, the time it takes to complete one full cycle, and I'll divide it by 4. And that will help us determine what really we should put on our scale. And you'll see where that's going to come into play on the next page. I think I said D here. I think we meant C. So C, notice what's happening. The normal curve is the red one. +1 is the blue. +2 is the green. And -1 is the black. Minimum and maximum. So the min is equal to C minus the amplitude, or C minus A. The max is equal to C plus the amplitude. Now C is really the midline. C is really the midline. It's the vertical shift Wait, hold on. I got to read because I don't like the way this is worded. All right, that's kind of worded right. It's the vertical shift. The vertical center between, and I know I'm getting behind my head, the max and min. And quite honestly, this is where you're going to start your graphing. Every time I ask you to graph it, you're going to start there. So the midline, let me draw it on this. I'll draw it for the midline for this one, this +2. All right, that's this green one. Here's the midline. It's the vertical center between the max and the min. The vertical center between the max and the min. I have to circle a couple of things to fix for when this goes to print. All right. So let's just work with this. And we're going to see how this works. So A is 2. Oops, let me get off that behemoth. Let me pause for a second. I'll be right back. All right, for the next couple of pages, we're going to practice graphing these. I'm not exactly excited about graphing this over 2 pi. And I'll explain why in a minute. So normally that's the normal distance to graph it over, but we'll see if I'm going to do that or not. I might change it. So right now A is 2. B is 1. Now remember, period is defined as 2 pi over B, which is 1. So that means it's just going to finish 2 pi. X scale is period, which is 2 pi, divided by 4, which is really just pi over 2. Okay. My C is 1. And if you remember correctly, max and min are A minus C. Remember, min is A minus C, which is 2 minus 1, which is 1. And max is 2 plus 1, which is 3. Now, in order to graph, I want you to graph the midline first. Well, let's get some scales up here. 1, 2, 3, -1, -2, -3. Now, here's my scale factor. Here's what I'm going to graph. So, pi over 2. Pi, 3 pi over 2, and 2 pi. Just counting by pi over 2's. All right, kids. First thing we're going to start with is our midline. So I'm going to graph that in this nice, thick black line. It's dotted because it's not really part of the graph. There it is. Now, a sine curve begins and ends. Well, this should not be 2 pi over 2. It should be just 2 pi. Sorry about that. And begins and ends at zeros. In the middle is a 0. In between there goes our max and our min. So in between these first is a peak. In between those two is a valley, the lowest number. I apologize profusely. I apologize. I screwed up this. Minimum, if you go back to what I said a few minutes ago, minimum is C minus the amplitude. I got that all backwards. So it's C, which is 1, minus the amplitude, which is 2, which is negative 1. And then C plus the amplitude, or 1 plus 2, which is 3. The 3 is fine. It was the negative 1 I wasn't getting at. There it is, lowest value. So lowest value, highest value. And there's our graph over 2 pi. So, yeah. This next one is going to be a little interesting. I'm going to make my decision just in a second. My A is 1. That's easy. My B is 2. My period is 2 pi over 2, which is just pi. Now, what does that mean? That means I'll finish one full curve in pi. Or, in other words, I'll finish 2 full curves in 2 pi. Now, my scale factor is going to be pi over 4, period over 4. My midline is negative 1, so this is going to be negative 1 minus 1, which is negative 2. Negative 1 plus 1, which is 0. So it's going to come as high as 0 and as low as negative 2. First thing we're going to do is draw in the midline. I got to find a different color. Let's try this one. Oh, I need some units. 1, 2, 3, negative 1, negative 2, negative 3. Okay, so this is where we have to be very, very careful. This is 0. And if I go out to 0 to 2 pi, this would be pi over 2. And this would be pi. I don't know why I said pi over 2. This would be pi. And this is pi over 2. And then this is 3 pi over 2. Now, it's going to get a little crazy. But I think we have to do it this way. So let's draw in the midline of negative 1. It's a dotted line because it's really not part of the graph. It's like a hidden line that we use. So here's the trick, and here's where it's going to get a little freaky deaky. I'm not going to finish one curve in 2 pi. Because my frequency is 2, I'm going to finish 2 curves in 2 pi. So the very first thing we're going to do is take care of one curve, and then we'll just duplicate it, all right? So I'm going to start at 0. I'm going to end at 0. In between is a 0. Now, the reason I said my scale factor is x equals 4 is because I ought to have one of those 5 important points every pi over 4. So between these two is a max. Oh, that's a pi over 4. In between these two is a min. There's pi over 4. That's another pi over 4 in between those two. And there's one full curve. So again, we're going to begin and end at a 0. In the middle is going to be a 0. At those pi over 4s in between are going to be my max and mins. That's why I'm going to need those as part of my scale. So my scale is really pi over 4, and that's what I should put there. And then I can, so that means every half a box is pi over 4. All right, this one's going to get even freakier. My A is 1/2. My B is 4. So that means my period is 2 pi over 4, which means I'm going to finish one full sine curve, one full curve in half a pi. That means I'm going to finish 4, well, how about this? 2 full curves in pi, or 4 full curves in 2 pi. So here I finished one curve. Here I finished 2 curves. Now I'm going to finish 4 of them in 2 pi. This is going to be like a wiggly thing. Now my x scale is, what am I going to represent my x scale is? Well, that's pi over 2 divided by 4. Well, that's really pi over 8. Remember, this is over 1 multiplied by the reciprocal. C is 2. So 2 minus 1/2 is 1.5 equals 1.5. I don't like decimals, but we'll leave it there. And then 2 plus 1/2 is 2.5. All right, we need some stuff on here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I'm going to graph it over 2 pi. This is going to get crazy. Let me draw in, oh, and I need 1, 2, 3, -1, -2, -3. So let me draw in my midline. I'll do it in green. My midline is 2. Okay. All right, so let's try to graph this thing. Here's the trick to this one. It's going to take, we're going to finish one full curve in pi over 2. So that means it's going to start at a 0, end at a 0, and it's going to be 0 in between. We're going to go up to 2.5. That's going to be our maximum. And down to 1.5. That'll be our minimum. So we're going to go up here and down here. One full curve in pi. That means I'm going to finish another full curve in the next one. It always freaks me out when it does that. Another full curve in the next one. And finally, we'll end with one more full curve over 2 pi. 4 full curves in 2 pi. Notice what's happening. Frequency 1, 1 curve. Frequency 2, 2 curves. Frequency 4, 4 curves. Man, crazy. All right, try this one on your own. I would pause it, try it on your own. Pause it. Welcome back. 3. 1, 2 pi over 1, which is just 2 pi. My x scale is going to be 2 pi over 4, which is just pi over 2. Now, by x scale, I guess what I'm talking about now is every peak and valley are going to be at every pi over 8, I guess. This one is, I've just got to worry about pi over 2s. So this one, nothing special here. Pi over 2, pi, 3 pi over 2, and 2 pi. C is -2. Take -2, subtract 3. I get -5. That's a problem. Oh, wait, maybe not. -2 plus 3 is +1. There's your max and mins. 2, -2. That means this is -5. That's good. We'll get there. And this is 5. All right. First things first, we're going to put our midline in. Do it in green this time. Our midline is -2. Now the cool thing is I only got to finish one curve. So I'm going to start at a 0. I'm going to end it at 2 pi because it's going to take 2 pi to finish one curve. That means halfway in between is a 0. And then halfway in between those are our mins and our maxes. Well, our max is 1. Our min is -5. And there it is. All right, so this one we're going to work backwards. Given the function, I want you to put in all the information. All right, midline is where we start. It goes right through the beginning and end point, so there it is right there. So my midline is 2. My amplitude is this difference, or this difference. Absolute value, it's a half. So 1/2. My period, how long did it take to finish one full curve? Period. The time it takes to finish one full cycle. In this case, it's 2 pi. Frequency. How many full cycles did I finish in 2 pi? 1. Now I'm ready for the equation. Y equals 1/2 is the amplitude. Sine. Remember, frequency is really my B value. This is really my A value. And this is really my C value. So 1x, or just x, plus 2. There it is. All right, let's talk about midline. Doing this midline right here. Oh, that's just 0. Amplitude. Down 2, up 2. The amplitude is 2. It has nothing to do with being positive or negative. It's just 2. How high did it go from the midline? How many curves did I finish in 2 pi? I only finished, what is my period? The time it takes to finish one full curve. 2 pi. And my frequency, how many curves did I finish in 2 pi? 1. So remember, this is B, this is A, and this is C. So my equation this time is y equals 2 sine 1x plus 0. I don't need plus 0. Now the only difference is I went down first. And because I went down first, I need to have a negative. So that's just -2 sine x. Another mistake. All right, finally, we've got 2 left and we're finished with this day, I think. Number 7. Let's throw that midline in. There it is. Hard to tell when you don't see the full curve, but that's it right there. We went up 1. So my midline is -1. That's the C value. My amplitude went up 1, so that's 1. That's our A value. Period. The time it takes to finish one full curve. Well, I've only finished the top half of the curve in 2 pi. So that means that it's going to take 4 pi to finish a full curve. And remember, frequency is how many full curves did I finish in 2 pi? How many full curves did I finish in 2 pi? I only finished actually a half because it only got halfway through. So my equation is y equals, we went up first, so it's positive. A is 1, so it's just sine. I only finished half of a curve. Remember, this is my B value. -1. All right, you guys try this one on your own. Make sure you know how to do it. Pause it. Okay, there's my midline. So I'm going up 2 and down 2. So my midline is -1. My amplitude is 2. Period. How long does it take to finish one full curve? One full curve is right here. Up, down, and back up. How long did it take? Oh, pi. How many full curves do I finish in 2 pi? Oh, I finished 2. Remember, midline is C, amplitude is A, and the frequency is B. So my equation for this one is going to be y equals, we went up first, so it's positive, 2 sine 2x, and then the midline, -1. And that's all she wrote. That's it for, what are we on, 7.7. That's it for 7.7. Please hit the subscribe button, hit that like button. Let me know what you think. If there's anything still confusing, you can always send me a message. If I have time, I'll try to get that on. I don't always have time, but who knows? Maybe you'll catch me on a good time in my life. All right, Ms. Newman and I thank you very much, and catch you on the flip side.